Hi everybody, in this video we're going to go over summations and product of sequences. I have a lot of worked examples that will show you both the sigma and pi notation. Well, let's get started by looking at our notation. We use sigma to stand for summation. In that summation, you will have a lower bound and an upper bound that tells you where to start and stop the summation. It's important to note that the index can start anywhere, not just at 1. To do a product, we use a pi notation. And this is really the same structure as sigma, but now we're going to multiply instead of add. Let's take a closer look at how that works with some examples. We'll start with the sum of I equals 4 to 7 of I cubed. Looking at the indices of 4 to 7, that tells us we're going to have terms for I equals 4, 5, 6, and 7. We'll find the sum of 4 cubed, 5 cubed, 6 cubed, and 7 cubed. If we evaluate each of those cubes, we get 64 plus 125 plus 216 plus 343, which gives us a grand total of 748. You could, of course, use your calculator to go directly from step 1 to step 3, but I want to show you each of the steps as we go through this video. For example 2, we're going to use a product. This product is going to go from I equals 1 to 8, and our term is given as I. So this time, when we use our factors 1 through 8, we're multiplying 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8. And maybe you recognize this pattern as the factorial, which we write as 8 with an exclamation point. So now when you either multiply all the terms together or push 8 factorial on your calculator, you'll get 40,320. And here, typing 8 factorial in your calculator is much easier than typing in each factor to get the product. If you don't see the exclamation point on your calculator, it might be hidden under a button that says PRB for probability. Let's build on top of the factorial and find the sum of n equals 1 to 5 of n factorial plus 3. Here I changed the letter for our index just to show you that it doesn't matter which letter we use. Just like before, we want to think about the values we're going to plug in. This time we're plugging in 1, 2, 3, 4, and 5. We'll have 1 factorial plus 3, 2 factorial plus 3, 3 factorial plus 3, 4 factorial plus 3, and 5 factorial plus 3. Our next step will be to evaluate each of the factorials and then add 3 to the result. Again, you could do this in your calculator. This gives us subtotals of 4, 5, 9, 27, and 123, which when we add all together, we get 168. Let's jump over to the calculator just to get a quick view of how to make this easier when we're doing our work. If you want to see each piece of your sequence, you can type 1 factorial plus 3, then 2 factorial plus 3, 3 factorial plus 3, 4 factorial plus 3, and then 5 factorial plus 3. Now we can add the 4 plus 5 plus 9 plus 27 plus 123 to get our grand total of 168. Example 4 has us finding a product that contains a variable. We have n equals 3 to 6 of n times x plus 4. The n in the product will change, but the x will stay the same. We'll start by writing out the factors for n. We're starting at 3, and we go all the way up to 6, so n will take on the values of 3, 4, 5, and 6. When we plug that in, we have 3 times x plus 4 times 4 times x plus 4 times 5 times x plus 4 times 6 times x plus 4. So we have two things right now. We have constants and we have the factor of x plus 4. So we're going to separate those. This gives us 3 times 4 times 5 times 6 times x plus 4 to the 4th power. We can multiply the constants to get 360 times x plus 4 to the 4th. The trick here is that a repeated factor like x plus 4 becomes x plus 4 to the k, where k is the number of terms. Our last example is the product of two sums. I have n equals 1 to 5 of 2 to the n times k equals 1 to 4 of k squared plus 5. Let's start by looking at the first sum. We have the sum of n equals 1 to 5 of 2 to the n. That means we have 2 to the 1 plus 2 squared plus 2 cubed plus 2 to the 4th plus 2 to the 5th, which is 2 plus 4 plus 8 plus 16 plus 32, which is a total of 62. Our second sum is the sum of k equals 1 to 4 of k squared plus 5, which gives us 1 squared plus 5, 2 squared plus 5, 3 squared plus 5, 4 squared plus 5, for a total of 50. Once we have the two sums, we multiply 62 and 50 together to get our final answer of 3100.